Hi YouTube, Tim Uckert here. In this video, we're going to divide complex numbers. So let's look at problem one. We're simplifying this expression. We have 3 plus 2i over 4 plus 5i. So the fraction bar there indicates division. So 3 plus 2i is being divided by 4 plus 5i. And I'm just going to rewrite the problem down here so we have a little extra room. And what we need to do is we need to get rid of the complex number in the denominator. And we can do that by multiplying both the top and the bottom of this fraction by the complex conjugate. So what is that? Well, it's basically you take the real number here, you take the imaginary part here, and you just change whatever the sign is here. So the complex conjugate of 4 plus 5i is 4 minus 5i. So we're going to multiply the top and the bottom by 4 minus 5i. Okay, so what happens on the top? Well, when we do the top, we do our first term, so 3 times 4. And then we add that to our outer term, so plus 3 times a minus 5i. We then add that to our inner term, so 2i times 4. And then we do the multiplication of our last terms, which is 2i times negative 5i. Just got room there. Okay, and then on the bottom, again, we do the same thing. So 4 times 4, plus then 4 times minus 5i, or negative 5i. And then we do 5i times 4. And then we do 5i times minus 5i, so plus 5i times minus 5i. Okay, so let's work this out. So 3 times 4 is 12. And then we have 3 times minus 5i, so plus a negative 15i. And then we do 2i times 4, so that's plus 8i. And then we do 2i times negative 5i, so that's negative 10i squared. I squared is negative 1, so it's negative 10 times negative 1, so it's plus 10. And then on the bottom, 4 times 4 is 16. 4 times negative 5i is negative 20i, so we have plus negative 20i. Okay, and then 5i times 4 is plus 20i. And then 5i times negative 5i is negative 25i squared, which is actually positive 25 because I squared is negative 1. So what happens here when we multiply the um, denominator by the complex conjugate of the denominator, the i's will cancel out and we're left with just a real number. So both the minus 20i and the plus 20i will cancel each other out. We're left with only 16 plus 25. So we can start to simplify this now. So this is going to equal 12 plus 10. So 12 plus 10 is going to be 22. And then plus, we have negative 15i plus 8i is going to be a minus 7i. And that's all going to be over 16 plus 25, which is 41. We can then separate this into 22 over 41, so that's the real number part. And then plus a negative 7i, or just minus 7i over 41. And there we go. That's about as simplified as we can get for this one. So I'm going to erase some stuff and then we'll get to our second problem. So in problem 2, we have 2 minus 2i over 1 minus 4i. So we're going to take 2 minus 2i over 1 minus 4i, and we'll multiply by the complex conjugate of the denominator, so 1 plus 4i. Okay, so when we do that out, first term times first term is 2. 2 times 1. Outer terms, 2 times 4i is plus 8i. A negative 2i times 1 is minus 2i. And then a negative 2i times 4i is minus 8i squared, or just plus 8, because I squared is negative 1. Okay, and then on the bottom, if we remember from before, when we multiplied the denominator by its complex conjugate, the outer and the inner terms cancel out. So we're just going to multiply the first terms together, 1 times 1, which is 1. And then we're going to add that to now a negative 4i times 4i, that's minus 16i squared, which is just plus 16. Okay. So now, when we combine these together, we get 10 plus 6i. And that's all over 17. We can break this apart into 10 seventeenths plus 6 seventeenths I. And that's it. We're done with the second one. Okay, let's keep going. Okay, maybe at this point you want to pause the video, try it yourself, and see if your solution matches mine. Also, smash the like button. And also, when you're doing that, be careful when you're doing this one, because we have an I first before the real part. So be careful when you come up with the complex conjugate. So let's take a look at this one. We have 3 plus 2i over I minus 3. We want the i's to cancel out. So another way we could write this is negative 3 plus I. That's going to allow us to see what the complex conjugate is a lot easier. So we're going to multiply by negative 3 minus I. Okay, then we do that. We do 3 times negative 3, which is negative 9. 3 times negative I, which is minus 3i. 2i times negative 3, which is minus 6i. And then 2i times negative I, which is negative 2i squared, which is plus 2. Okay, we're going to just square the first term. So 3 times, or negative 3 squared is 9. And then we have I times negative I squared, so it's plus 1. All right, so we want to combine our like terms here. So we can add negative 9 and 2 to get negative 7. And we have minus 9i. We combine the 3i and the negative 3i and the negative 6i. And that's over 10. Now, if we want to split this apart, this is going to be negative 7 tenths. And then just minus 9 tenths I. Like so. Okay, hopefully you got that one. Let's keep going. So I'm going to erase this and we'll go to our fourth problem. All right, in our fourth problem, we've got 4 minus 5i over 4i plus 2. Same thing, we have to be careful with this one. So I'm going to do 4 minus 5i. And we're going to switch this to 2 plus 4i. That'll help us to determine the complex conjugate of the denominator a lot easier. Okay, so now we're going to multiply both the top and the bottom by 2 minus 4i. Okay, so we're going to do 4 times 2, which is 8. Then 4 times minus 4i, which is minus 16i. Then we'll do minus 5i times 2, which is negative 10i. And then negative 5i times negative 4i, which is going to be a positive 20i squared, which is actually going to be minus 20. And then on the bottom, 2 times 2 is 4. And 4i times minus 4i is going to be, it's going to be negative 16i squared, so that's going to be plus 16. All right, so if we combine our like terms, 8 minus 20 is minus 12 or negative 12. And negative 16 plus negative 10 is negative 26i over 20. So we'll break this apart, and then we can actually simplify this one a bit. So we have negative 12 over 20 minus 26 20ths I. All right, so negative 12 20th, we can simplify that into negative 3/5. Again, this is, make sure that's a 20. It looks like a 20. And then we can have minus 13 tenths. We can simplify the second fraction. Minus 13 tenths I. And that's it. So we have negative 3/5 minus 13 tenths I. Is our solution to the last one. Hopefully you enjoyed this video. If you did, please like and subscribe, and I hope to see you in the next one. Bye.